All right, so we are doing section 3-4. We kind of started it a little bit yesterday. What did we talk about yesterday? Do you remember? We didn't even talk about distance at all. Yeah, we did that coordinate plane stuff, okay? We did the grid thing, the graph, right? The ordered pairs, all that kind of good stuff. Okay. Aziz, you got a quiz to take? Yes. So come on up. Come on up. I think there's a chair right around the corner there. You can just sit right there and take it. Thank you. All right, yeah, so we did that. You know, we did the, let's try this again. Let's go like this. I gave you that nice, pretty grid, right, with all the blocks in it and stuff like that. But let's just review quickly. We call this line right here, what do we call this thing? The x-axis. We call this one the y-axis. Okay, we call this area right here first quadrant, second, third, fourth. Okay, we said if we had a point right here, that's an ordered pair. Do you remember that? The ordered pair is xy. All right, so you go over on the x, go up on the y, or go down or go left, whatever direction it is. I don't know. What else did we talk about? That was pretty much. Okay, yeah, we said if you go to the left, it's negative. If you go to the right, it's positive. If you go up, it's positive. If you go down, it's negative. All right, the origin, very good. Right here is the origin. That's the beginning. That's where you start. Okay, all right, that pretty much covers it. So that's what we talked about yesterday. So we're going to use some of that stuff that we talked about yesterday. If I can, there we go. And we are going to do some stuff with it. So, let's do this. Let's actually, well, where do I want to go with this? Tell you what, let's do one more review thing, something that you probably did in Algebra 1, but we're going to review it, all right? Because, you know, I don't assume that you remember everything that you learned in Algebra 1, obviously. So what I'm going to do is draw a triangle, but it's a specific type of triangle. We've already talked about several different types of triangles, so you should know what kind of triangle this is. Okay, is it a right triangle the way it's drawn right now? No, we don't know it's a right triangle yet, but no, there's no left triangles. So if I did this, now what could you say about this triangle? Now you could say it's a right triangle. Okay, you learned something back in Algebra 1 that we call this, the two sides right here, we call them the legs of the triangle. And we call this the hypotenuse, right? We discussed that earlier in the year as well when we talked about the different triangles. Okay, just listen to me. So a lot of times we'll call this side A, we'll call this side B. Now it doesn't really matter which side you call or what leg you call A or B. It makes no difference, okay? It does make a difference what we call the hypotenuse, and we're going to call it C. Now I could have called this B, and that would have been fine. I could have called this one down here A, that would have been fine. But this one right here, the hypotenuse is opposite the right angle. The hypotenuse must always be C. We had a little formula. Now this is not technically the distance formula, but we're going to use this thing in order to do the distance formula. Okay, so we need to remember this a little bit. And we started off with this. Do you remember this? A squared plus B squared equals C squared. Do you remember that? I don't think we mentioned that this year, have we? I don't know. Did we? I can't remember. Anyway, we gave it a name. What do we give the name of this little formula right here? It's not a slope. Doesn't have anything to do with slope. It's got some crazy name. You know how he said Cartesian plane and it was named after some old guy named René Descartes? Well, this is also named after some old guy, way before Descartes, actually. I think. I'm not really sure, but I think it was BC this guy lived. I'm not really sure. I can't remember. We could look it up. Not going to. Anybody remember it? Anybody say it yet? P. Starts with a P. That's it. You got it. Right? Pythagorean Theorem. I'll just put it right here. Pythagorean. It's named after a guy. His name was not Pythagorean. All right, it's like if you're from Philadelphia, you're a Philadelphian. If you're from Delaware, you're a Delawarean, right? Well, this guy was named Pythagoras, and so they named this theorem after him, and they called it the Pythagorean Theorem. But his actual name was Pythagoras. Pythagoras. He was a Greek guy, lived way back. I don't know. Let's look him up. Okay. So, Pythagoras. Oops, there we go. Pythagoras. Let's see. When did he live? 1997. It was BC. Look at that. 500 years. Listen. Shh. Up here. I'm up here. I'm up here. Up here. It's just, it doesn't matter. It still works. Okay. It's taken from other trusted sources, so Wikipedia is fine. Okay, for what we're doing. All right. He's Greek. It's ancient Greek. And look at the dates. 570 to 495 BC. That's 500 years before Christ. All right. We think that was a long time ago when Jesus was on this earth, and it was. But he lived 500 years before Jesus. All right. So he goes a long ways back. What? He probably knew all this. Yep, they probably taught it. Now, let me tell you this. The Pythagorean Theorem, it's named after him not just because he came up with it. They actually knew this thing right here with right triangles. And you're like, well, why did an ancient Greek person need to know about right triangles? Well, they had buildings, right? The Greeks, I mean, they built beautiful, beautiful buildings that are still standing today, that were built, you know, literally thousands of years ago, and they're still standing today. And part of the reason is because of the Pythagorean Theorem, all right? Not all together because of him, but he didn't actually come up with it. They knew about this theorem long before. Casey, up here, please. They knew about this theorem long before Pythagoras was around. But Pythagoras was the first one to actually prove that it was true, all right? We're not going to prove it. In other math classes, you might prove it, but we're not going to actually prove it in here. There's probably a proof in the book, to tell you the truth. That's a very common geometry kind of thing to do. We're not going to prove it, but he's the one that actually proved this thing to be true. That's why we named it after him. Not we. I didn't name it after him. It was named after him long time ago. So let's figure out how to do this. The distance formula does have something to do with this, I promise you. All right, so let's do this. Tell you what, let's just, let's just keep that C, all right, for right now. What if I said the length of that was 3 and the length of this was 4, and we wanted to find the length of the hypotenuse, or side C? So look at the theorem. Look at the formula that they gave us. It's a squared plus b squared. Which one was the a on this one? The 3, okay? And it could have been the 4. It doesn't make any difference which one's which. It does make a difference which one the c is, okay? So the a was the 3. So what are we going to do? We're going to use this formula right here. So we're going to go 3 what? 3 squared, because that's what the formula tells us to do. And then we're going to put a plus, and then we're going to take this b, and then we're going to square that. What is the b? It's 4, and we square that. And that should equal what? C squared, okay? Or the hypotenuse squared, okay? Let me just check this. Okay. All right? Now what we want to do is what? What do you think we're trying to solve for here? Well, more specifically, not just c squared, but c. We just want to find c. We want to find the length of this hypotenuse, okay? Everybody with me? Okay. So I got to solve for c right here. So let's do that. Let's figure out what this stuff is right here. 3 squared. What's 3 squared? 9. Plus, what's 4 squared? 16. And that should equal c squared. Let's do the rest of it. 9 plus 16? It's 25. Okay, equals c squared. Does that mean the length of this is 25? No, it doesn't. Okay. Now watch. This is something that maybe you did in Algebra 1. Maybe you didn't. Let's move this up a little bit so I don't have to... Oops. I wish I could grab this. There we go. Okay, let's move it over here. So what we're going to do is we want to get c by itself. Do you remember back not long ago, because we've been doing this stuff lately, remember if I had something like this and I wanted to get x by itself? Bryce, turn around. Okay, you do the opposite. Remember that? Because what is that 3 doing to the x? It's multiplying. So how do we get rid of the 3? We divide it, right? So we do the opposite of something. If I had this, if I had x plus 2 equals 5, I want to get rid of the 2 because I want the x by itself, so I do the opposite. What's the opposite of adding something? I subtract something, okay? You with me on that? Okay, that's just off to the side. That's just to get you thinking about doing the opposite. So let's look at this. This is c squared. What's the opposite of squaring something? Taking the square root of it. Exactly right, okay? So what we're going to do, the way to get rid of that squared is to take the square root of it. So for instance, if I had 3 squared, what's 3 squared equal to? It's equal to 9. What if I wanted to go back to the 3? What would I do with that 9 in order to get a 3? I could take the square root of it, right? Doesn't that kind of undo it? So look at this. If I took the square root of a square, basically what happens to the square root and the square? They just cancel out, right? So the square root of 9 is 3. Make sense? So let's look at this. How do I get that c by itself? I take the square root of it. Now in algebra, if I do something to one side, I've got to do it to the other side. So if I take the square root of this side, I have to take the square root of this side. You with me? So c equals, what's the square root of 25? That's easy. What's the square root of 25? It's 5, right? 5 times 5, right, is 25. So c is 25. So what's the length of this hypotenuse? It's just 5, okay? Let's do another one, but let's make the triangle just a little bit weirder, like the numbers just a little bit different. I don't know, I just have a habit of always writing my right triangles like this. You don't have to make them look like this every single time. And let's do this. All right, put a little box right there. That's a right triangle. What if this was 2 and this was 3? Okay, and I wanted to find what c was equal to. So let's put it in the Pythagorean Theorem. Now, I said a squared plus b squared equals c squared. You could go the other way. If you're trying to solve for c, sometimes I like to put c on the left, okay? So is that all right if I do that? Just put c squared equals a squared plus b squared. So what's the a and b? Well, it doesn't matter which one the a and b is as far as it's the 2 or the 3, right? It doesn't make any difference. So I'll just do the 2 squared plus 3 squared, okay? So let's figure out what this is. What's 2 squared? It's 4. What's 3 squared? It's 9. So c squared equals, what's that? 13. That's not my answer. That's not how long the length of side c is. I got to square root it. So I square root this side, square root this side. So c is equal to the square root of 13. And that's kind of weird. Most high school students don't like that. They don't like, because I can't take the square root of 13 and get an even number out of it, can I? I could do it to 25, right? Because I just got a 5. Worked out really nice. But you could just leave it. I'm perfectly fine if you just leave it the square root of 13. But the book will probably write it as a decimal. So what do? How do we find what that decimal is? Pull out the calculator, right? So let's clear all that stuff. And so on my calculator, this is what I'm going to do. I'm going to hit second function and that right there. Oops, I thought I was going to hit it. There we go. Oh, that's not what I want. Let's clear this again. What's going on? Second function. There we go. That's what I want. See, it says square root, and then I put 13, and then I just hit enter, and look what it is. It's like 3.6 something, okay? So this is approximately, now why would I say approximately? Why didn't I say exactly? Because see, this doesn't stop. This keeps on going, right? If the calculator allowed it to go more decimals, it would go on forever. Literally, it would go on forever, right? It doesn't like repeat numbers forever, even though you do see a little repetition right here. But I say approximately. Just round it to 1 decimal place. So it's 3.6, okay? Well, if you have a graphing calculator, see, if you have a scientific calculator, Like I mean, does anybody have a scientific calculator on them real quick? Just show it to everybody. On a scientific calculator, you actually wouldn't put the square root first. Hold that up to just show everybody. Okay, see this calculator over here? Okay, that's a scientific calculator. If you have one like that, you don't put the square root first. You would put 13 first, and then you'd hit the square root button. And how did I get to the square root button here? I hit second function, this button right here, because of that square root. I know it's kind of small. If yeah, it depends on your calculator. There are some scientific calculators that you push the square root first, and then you hit the number. But there's some calculators that you hit 13 first, then you hit square root, and it'll give you the same exact number. So you have to know how to use your calculator. It's very important, okay? Because if you're not going to write it as a square root and you're going to write it as a decimal, you're going to have to know how to do this in a calculator, and you're going to have to get a calculator if you don't have one. Okay? I mean, you can go to Walmart or the drugstore, go to I don't know what drugstore is around. Walgreens, right? Couldn't think of the name of it. But you could go get one for probably like $10, all right? A scientific calculator. They used to be really expensive, but now they're super cheap, all right? So anyway, make sure you know how to use a calculator. I'm not here to teach you how to use a calculator, but I will show you some hints from time to time. All right, enough of that. Let's just get rid of that calculator. And let's now find out why in the world do we want to learn the Pythagorean Theorem. So here's what they're going to ask you. They're going to ask you a question like this. They're going to say, find the distance. So this could be a quiz or a test question. Absolutely. This will be on the homework. Find the distance between, and then they're going to give you 2 points. And I'm just going to give you the 2 points right here. So -2, 5 and 4, 1. So what I'm going to do is I'm going to show you on the graph how to do it, but then I'm going to show you the formula that you can just plug it into. So you don't really have to graph these. But I'm going to graph it first just to show you where this formula comes from. Is that all right? Okay. Let's see. It's Wednesday. What time? 15. Okay, I thought it was. I wasn't sure. Okay, so what we're going to do is we're going to graph this thing. And let me grab this graph so we got a nice little pretty graph to work with. Let's move this down to there. Let's put the graph there. Let's make it just a little bit bigger so we can see it. There we go. There we go. Now, in order to find the distance, you do not have to graph this. Again, I already said this once, but I'll say it again. The only reason I'm doing this, let's see, it's this one. The only reason I'm doing this is to show you where this formula comes from. I could just throw out the formula and say, this is it, this is how you do it, get it right, boom, we're done. All right, I could do that, but the teacher in me just doesn't allow me. I got to show you where this formula comes from, okay? So it says, find the distance between these 2 points. Well, let's plot the 2 points, okay? Remember we did this yesterday. So we start at the origin. We go -2 on the x, and we go 5 on the y. So I go -2 on the x, so 1, 2, to the left, and I go up 5. 1, 2, 3, 4, 5. So I'm going to put a point right there. Let's put the other point in there, 4, 1. So I start at the origin, I go to the right 4, 1, 2, 3, 4, and I go up 1. All right, and what I'm going to do is I'm going to connect those 2 points because I want to find the distance between those 2 points. I want to find the length of that. Everybody see that? Okay. How in the world do I do that? Can I just count? 1, 2. No, you can't, because see how it goes like in between those grids right there? You can't really count accurately, right, how long this thing is just by counting. What if it was just straight across or straight up and down? Could you count? Yeah, absolutely you could. So let's do that. I'm going to do this in a different color. So why don't we do this? Why don't we start from here and go to here? All right. And then we're going to go, I'll tell you what, let's do this in a different color. Let's do this in blue. Let's see if blue shows up. We'll do it from here to here. All right? Look what we just formed. We just formed a what? A right triangle. That's right, because this is vertical, this is horizontal, so that is a right angle right there, okay? But what I'm going to do is I want to find the distance of the yellow one. So I'll get a length, right? I want to find the distance of the blue one. I'll get a length. And then I'm going to do Pythagorean Theorem. And then I'm going to be able to find the red one. All right? Well, that's how we get the formula. You could do it like this every time. But what if they give you like negative 37, positive 58? You don't want to have a graph and go out negative 37, positive 58, do you? No, that would be a pain. Right, it would. So we need to come up with a formula that we can use real big numbers, and it really won't be that hard, okay? So all I'm doing here, again, listen to me. All I'm doing right here is showing you why the formula is what it is, okay? So what was this point up here? Let's change it to red. This point up here, what was that point right there? Negative 2 what? 5. Okay, and what was this point down here? That was 4, 1. Okay? Now let me ask you this. Where is this point right there? Very good. It's negative 2, 1. Okay? So I'm going to put that in there too, because that could be very helpful to us. Now let's go back to the yellow. What I want to do is I want to find the distance between this point and this point, because I want to find out how long that yellow line is. Do you know how to find the distance? Did we talk about this? I think we talked about this. Yeah, we talked about the line segments. I don't know if we did or not, but let's say this. Let's say you're on the road, right? And you're going from here to here, right? Like this. And you're at the mile marker. So let's say you're at mile marker 7, and right here you're at mile marker 10. What is the distance between those 2 points? How long is that point, or is that line segment right there? It's 3. How did you get it? How did you get 3? It's not that hard. You got a 10 and a 7. Thank you. You just subtract it, right? So to find the distance between those 2 points, you just subtract. It doesn't matter what order you subtract them in. I could have gone 7 minus 10, but distance is always measured positively, okay? Dominic, I'm up here. It doesn't matter what order you subtract them in. You could go 10 minus 7 or 7 minus 10. But what's 7 minus 10? It's negative 3, isn't it? But distance is always positive. We never say, oh, I'm going to walk negative 3 meters or negative 30 yards. I don't do that. I just say it's positive. So forget about the negative part of it. Okay? You with me on that? So what's the distance from 7 to 10? It's 3. How did we find it? We subtracted. So let's take a look at this. Where are we on the y? Up and down. Where are we? We went negative 2, 5. So we're at the 5 right here, aren't we? Do you see that? And where are we on the y on this point? We're at the 1. So how do you find that length right there? That's right. You go 5 minus 1. So what's the length of that yellow line right there? It's 4. Let's do the blue. Let's do the same thing with the blue. Okay, where are we on the x this time? See, we're going across like this. Where are we on the x right here? How far over did we go? We went to the what? This point right here. I just made it blue. It was red. I made it blue. How far over did we go from the origin? We went over 4. That's right. Thank you. Where are we right here on the x? How far over to the left did we go? We went over negative 2. Not 2, but negative 2. Okay? Everybody see that? So let me just redraw it for you. So it's kind of like this. It's not the same size, but that's okay. So we were at negative 2 here, and we're at positive 4 here. What am I trying to find? I'm trying to find that distance. How do I find the distance? I do what? I subtract. That's right. And it doesn't matter what order you subtract them in. You could go negative 2 minus 4, which is what? Negative 6. But we always make it positive. Okay? I don't want to confuse you too much, but if you put absolute value symbol, absolute value always makes it positive. Or you could subtract the other way. You could go 4 minus negative 2. What's 4 minus negative 2? Add a line, change sign. Remember that? So what is that? It's also 6. You guys following or not? I'm asking you simple little questions. I'm hardly getting any answers. Okay, it's 4 minus negative 2, which is 4 plus 2, which is 6. So what's the length of this blue line segment right there? It's 6. So if I've got a 4 and I've got a 6, how do I find the red one, the hypotenuse? I do Pythagorean Theorem. Okay, I heard it. All right, that's good. Let's get rid of this. Let's get rid of all this mess right here. Okay, let's go back to red because I'm going to find the red length. So what am I going to do? I'm going to go 4 squared plus 6 squared equals. Now, we called it C when we went A, B, and C, but we are finding the distance, aren't we? So why don't we name it what? Let's name it D for distance. How about that? Is that all right? Is that going to confuse you if I call it D when we called it C before? Shouldn't, okay? Still the hypotenuse, right? So we're going to find D. So let's do that. What's 4 squared? 16. 6 squared? 36 equals D squared. And this is 52, which is equal to D squared. But we don't want to find D squared. We want to find D. So how do we find D? Square root both sides. And so you could keep it just D equals the square root of 52. All right? But I think if you look in the book, you look at the answers the book gives you, they're going to give it to you as a decimal. So let's clear that. Oops. All right, and so let's do the square root. So square root of 52. Make sure you can do this in your calculator. All right, and it's 7.2. All right, we'll just do it right here. So it's approximately. I shouldn't put an equal sign here, should I? I know I'm being super picky about it, but that's all right. So we'll say 7.2. I would be fine on a quiz or a test if you just left it like that, okay? But what I'm saying is when you look in the book, all right, and you look in the back to see if you got the answer right, they're going to put it as a decimal. So you need to be able to know if you got it right, okay? So on a quiz or a test, I'm perfectly fine if you put just the square root of 52, all right? But the book is going to write it like this, and you just have to be able to know that that's still the right answer. I wouldn't mark it wrong if you didn't put a squiggly thing. I would not. I would not mark it wrong if you didn't put a squiggly, okay? I'm just being super picky about it, okay? Just put square root of 52, and you're good to go. All right, all that said, no, we're not finished. Oh, well, it looks like we are because time's about to run out, okay? Yeah, I was supposed to give you homework today, but I didn't quite get to the formula. So it's not the formula. Remember I said you could do it like this, okay, but I did this to show you the formula. So what we're going to do, since time's running out on me here, tomorrow I'm going to show you the distance formula, okay, so that you can just plug numbers into it, work it out, and then you don't have to graph it. I just did this so you could see where the formula comes from. So hopefully you wrote that down in your notes. Tomorrow we'll pick right up, and then you'll see what the formula actually is, okay?